Hey everyone, today I want to take a look at this Shuyan, I think it's how you say Shuyan power inverter. This thing I paid like under 20 bucks and I've seen it listed at 650 watts, that's what this one says it is, but I've also seen it listed at 1600 watts, I've seen it listed at 400 watts, and they all look physically the same. So basically it's a inverter, so it takes 12 volts DC and it turns it into 120 volts ish AC, so you can run things off grid if you have a big enough battery or in your car. Now I'm suspicious of this thing, and that's why I'm doing a video on this, because it is super lightweight. This thing weighs 824 grams, or if you're in Libya, Myanmar, or the United States, 29 ounces or 1.8 pounds. Very light to be able to handle, even over 500 grams, 500 watts, I mean. Especially talking about, like, it has an aluminum case, it's got these fairly heavy lugs to put your wires onto. It's got 3 AC outlets, there's one on the side here, one there, and then there's also, some multimeters. There are, voltmeters, and there are also what I think is 2 sort of cigarette lighter chargers inside here for the USB. However, it could be a decent unit, especially for the price, like under 20 bucks. That's incredible. I found it luckily for that price. I don't think you'll reliably be able to find it at that price, but because they usually get bad reviews because they kind of are sucky, they'll often go on Amazon at a discount. So I will link to where you can find these, but I recommend only to buy them if they are dirt cheap, or if you want to abuse of Amazon's return policies for your own amusement. That's another option. So first things first, it comes with a cigarette lighter plug, which I believe in the mailbag I checked and was not fused. Yeah, correct. Not fused. So this is just the wire going directly onto the middle terminal here, which is sprung, and then the sprung negative here. It says it uses, let's see, where did it say? 18 gauge wire, and just looking at where it's soldered, it's pretty close, but I'd say it's a pretty thin 18 gauge. It's not I don't know if it's a true 18 gauge. However, on your car accessory sockets, you should only be expecting to use about 10 amps. So it's 120 watts. Okay, do the math. 120 watts. This thing says it can output 650 watts on the listing, and I've seen them up to 1200. I don't know. Your fuse will blow in your car well before you get to that. So got to be careful on that. Now, however, there is these sort of bigger clamps here, and they use a thicker wire. I mean, I'm looking at it, I'm trying to see sort of the thickness of the wire by the crimp, but they crimped it so far up here. It does seem like it's really thick insulation, and so I think it's more thick insulation than thick wire. But what we can do is we can cut, oh, there we go, there's the amount of copper in there, and in fact it kind of looks like aluminum to me. So I'm not sure about this. It's not even marked on what the gauge is, but yeah, I wouldn't be surprised if these wires are not really that good at all. Next thing to check is basically when you plug this into a power supply, it often has an inrush of current because of the capacitors inside that it needs to charge. Now, it's a bad thing to plug something in that sparks. So if this sparks, it's because it has, big capacitors inside here to charge up. But if it doesn't spark, that's even worse, because if it doesn't spark, that means that these 2 wires go through this little on-off switch here, which means you cannot install a pre-charger. So you can't install like a resistor to plug in, charge up the cap slowly, and then turn it on. So I'm of two minds. You know, I think I would much rather something that arcs when you plug it in than something that doesn't, because then you can, you know, pre-charge through a resistor. This is all things I want to do in my green energy projects, which are upcoming, and actually I'm working on them. This is one of the stages. And so, yeah, I'm going to set this up to be powered by the Readin 6018 to do our preliminary tests. And then when I draw too much current, then I'm going to move on and use a big battery. So let me get you set up for that. Got all hooked up here. Hopefully you can just be able to see the display. Now the power supply is off. The Readin's output is off. So instead of me just plugging in the cables onto a battery, we're just going to simulate that by pressing on here. And so it won't arc, but we're looking at this current here. Now it updates pretty quickly. So we're hoping to see, you know, very low numbers here. Actually, we're hoping to see high numbers here for an instant, because that would mean that we can pre-charge this. But let's see what happens. So I'm going to press on. No. That went to 0.2 amps. Really, I should be doing this with an oscilloscope and a clamp meter. And I may do that if there's enough request for it. But yeah, I don't think so. I think this thing is basically does not have any... No, I don't think it has any capacitors pre-switch, or they're tiny, because yeah, you see it's like 0.3. That's not enough. Okay, now let's see if we turn this on. So went up to an amp, and now it's just settled on half an amp. So 6 watts of continuous power draw, and so this says 116 volts out and 12.1 volts in. And so this you cannot leave plugged into your battery, because at a rate of 6 watts, unless you have, you know, full sunny days every day, this is going to drain your battery. So this is something you're going to have to turn on when you want to use it. So that's good. Okay, the next easiest thing to test is these ports here. So let me get an electronic load and we'll test the USB capabilities on this. Hopefully you can see all the relevant screens in shot. So this has, you can see the AC out voltage just barely. You can see the read-in, so you can see the input power. And then I got a high quality cable here. It's an OEM cable for some device or another. 24 wire gauge printed on it. I'm going to plug it into the 2.1 amps. So we're getting 5.08 volts without load. And we're going to try to pull 2 amps out of this. Oh god, it's already crashing. That's not good. Yeah. Trashed here. We're not even able to pull half an amp out of this. That can't be. Can that be 0.6? I'm going to try a different cable. I've got my pink light up cable that tested really well in my USB cable testing. Let's try that. Okay, it probably was just the cable. Oh, thankfully. I could also put another measuring device over here, but you guys wouldn't be able to see it, so. 2.6 amps, 4.4 volts, so you can pull 2 amps in here. I mean, it drops a little bit below the spec. I believe the spec is 4.5, but you can pull 2.2 amps at 4.5. So that's good. Let's check the 1 amp plug. It seems like you can pull the same amount from the 2.1 and the 1. So I feel like it doesn't really matter where you're plugged in. Oh, that says 2.4. This one here is 2.4. This one's 2.1. Let's go 2.4 then. Yeah. Yeah, still within spec. Okay. So that works just fine. I guess it's time for the dreaded AC test. So I've got my Unity UT81B scope multimeter sent in by David, a viewer. Now I know that this is fully isolated. I know that this is fully isolated. I know that between these two probes, there should be 10 mega ohms resistance. I can see the cat rating here, but I've never stuffed this meter's probe into an AC socket. So if I blow up your meter, David, I'm very sorry. Let's see here. Okay, so it should auto range. Let's go auto. Oh boy, too high. Times 10. Yeah, there we go. So let's see here. So that is very clearly a modified sine. It is not a pure sine wave. Let's see if I can change something here. Can you change the range? 10 milliseconds, no. Oh. Okay, moving up the voltage. How about the time? Can't move the time. Oh, time base. Don't know if I can move the time base, but you can see that's clearly a modified sine wave. It's not a clear, you know, up and down like you would expect. So this is not exactly, it's not a pure sine wave, first of all. Even though I'm pretty sure the listing did say so. I'm not sure if I can zoom in faster than 10 milliseconds. Give me a moment. I RTFM'd and I figured it out. Yeah, this is a modified sine wave. I also put some wires there so I can mess with this without having to hold that. It's a modified sine wave and not a good one either. Look at these like wide shoulders here. That's really interesting. I feel like I need to put a load on this thing on another outlet and see if this waveform varies. So yeah, one moment please. I believe it's a 100 watt incandescent light bulb. Might be a 60, but I think it's a 100. So I'm going to flip that on and we're going to see what happens to the waveform. Definitely not a 100 watt because we are only drawing 54 watts on the read-in here. Waveform doesn't look like it's changed very much. Obviously I was switching, so I may not have seen. But yeah, it is outputting. My bulb looks really dim though. Is it really outputting 100 volts? This is 20 volts per division. So 20, 60, 80. Oh, from peak to peak though. So 81, 60. Something's not adding up here. Time for another multimeter from the David collection. I'm just going to shove these probes into here. Oh, we're getting 114 volts. So my light bulb is getting full power, I think. Let's see if this is individually. Yeah, 114 volts AC. So that must be a really small bulb. Is it a 40 watt? Pretty confident it says 60 watts. So yeah, interesting. So anyways, that does work. Let's see if we can make it do a bit more work though. Got my hot air reflow station plugged in here. Don't really know at what temperature, but we'll see. Oh boy, that's overdrawing. That's not working. Okay, heating element. Not a good idea. This thing was freaking out. I didn't see the current here. Is the current here what's maxing out? Oh yeah. Oh boy. Off. Yeah, we're maxing out on the read-in, actually. This thing was trying to pull more current than that's possible, so I need to switch to a battery. Alright, got a massive battery over on this side and connected with the crocodile clips. Now, I shouldn't have to tell you this is a bad idea. There's no fuse here. The only fuse would be internal to here, and I haven't torn this down yet, so there may not be a fuse. Don't do this without a fuse. That simple. I'm going to do it here, and I'm probably going to regret my choices, but at least it'll be on camera. I've got this power meter from watcher RJM, who used to comment a lot but then deleted his YouTube account. So we're going to check my reflow station, the hot air reflow station. It's the WEP858D. I can link it in the description if you want one. I actually really like it. It is rated 6 amps, so that's, you know, under 700 watts. This thing says it can do 650 watts, I think, on the Amazon listing, so we shall see. First things first, let's turn it on. This thing will power on, and it'll tell us some interesting stuff. So 114 volts, and then I believe if you just change the display, I just want the watts, my friend. Time. Okay, I guess we can't see the volts and the watts. I guess the volts are here. Alright, so I'm going to turn it on. So this is just resting. It's pulling 2.5 watts. I'm going to turn down the fan, actually, and see how much current it draws. There it goes. Is working. Oh, it died. Hang on a sec here. Okay, here's the watts. Now watch it before it dies. Here it goes. Just about 500 watts it dies. That's not great. So this thing, it doesn't even have a peak number as high as they say. This thing just literally falls on its face at, you know, around 550 watts. Pretty weak thing, but not bad if you have the right equipment to use it. So like if you're only using this for, let's say, a rice cooker or, you know, some lights, you'd probably be okay. But man, 3 outlets is kind of useless on this thing because it doesn't really let you pull enough current. But again, for the price, not bad. Time to tear down this puppy. I am not a engineer, so this won't be sort of like a Big Clive style teardown, but we're going to take a look at what we can see on the inside anyways. In case you didn't know, these cases are extruded, so they're usually, you know, a tube with 2 caps on the end. So typically a good start is to take the caps off. Usually one cap will be more accessible than the other. And then, you know, you can unplug things, pull the cap away, and then usually there's a circuit board on the inside which you can slide out, or sometimes multiple circuit boards which you'll be able to slide out. Just be careful, because the case, the aluminum case, is usually used as a heatsink. And so if you look at here, these screws, they're probably solid state devices like MOSFETs or diodes screwed to the case. You're gonna have to remove those too. So I'm looking here, this is soldered. Oh my god, look at how thin those wires are. That is not a good sign. Typically there's one side that will be connectored and the other side will be soldered. So let's see if that's the case here. I know a fan typically has a connector, but there is a real possibility we're gonna have to desolder some stuff to be able to take it apart, because, you know, low quality stuff, solder is cheaper than connectors. Okay, so this side is bolted on, but I can't see. The fan will have to be unscrewed. It'll move through. We'll be able to undo the bolts on this side to pull this side through. So basically the board will slide that way. What I'm also worried about is there's these things which are usually clipped in they look like they're soldered as well. You know, I'm not sure I'll be able to get this back together again. That's not a good sign. Oh, but this is so crusty. Oh my god, is it ever crusty. Oh, here, I have an idea. No, I was going to unclip these. So first of all, the ground lug is not even connected, which is not surprising. These are tiny, tiny wires. Okay. I really want to get this apart. Ooh. So I'm at a crossroads here. Let's be honest. I want to use this thing, but I want to tear it down. So what do? Do you guys think I should tear it down or keep it intact? Thumbs up on the video if you want it torn down. Absolutely no thumbs down. Thanks guys, I guess I'm gonna have to tear down my toy. Well, here we go. So as it turns out, I am a moron. The top just comes off. Well, I'll be dipped. Let's take a look at this thing now then. First and foremost, it certainly seems like all the AC outlets are coming from this one little spot there. I don't know if that's live still. Nope. So they're using these tiny little wires. No wonder they don't want this to draw too much current. So that's that, and then the little DC output here. Yeah, alright, so this here is very likely just a cell phone charger type circuit. This here is the 2 voltmeters, and they're coming down here onto that. You got these big beefy wires coming in here, so that's nice. 2 fuses which appear to be soldered in. I'm gonna have to take this board out. Well, I am no big Clive, like I said, but I did take a look at this, and I want to show you a couple things that are interesting. So first and foremost, we've got 2 40 amp automotive fuses right here, but they are in parallel, which is really interesting. And so it's going to be like 80-ish amps before one of these blows. That's a lot of current. I don't know if I'd trust this in parallel, but on top of that, why would they put 2 in parallel when we noticed that, you know, after like 20 or 30 amps flowed, this thing was maxed out anyways? Not sure. Another thing is there are MOSFETs here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 MOSFETs. But 8 are doing the switching. 1, 2, 3, 4, 5, 6, 7, 8. They're switching. I think they're doing a push-pull configuration on these 2 transformers here, which are labeled. I don't know if you're going to be able to see the label. LQ 12 volts to 110 volts. So these 2 transformers are literally made for power inverters. These MOSFETs are IRF 650A. They are 200 volt maximum, 28 amp maximum, you know, pulsed current type thing MOSFETs. These 2 here are switching the negative cable here. And so when you switch on using this little switch in the back, this guy here, it actually switches on the negative into the circuit here, and you know, de-isolates from the battery, which is interesting. They take that 12 volt along and they go to this fan. So this fan here is a 12 volt fan. It's a tiny little thing. And then they also bring the 12 volts up through here, where this is just a little, this is the same circuitry you would see on a car USB charger. So I did test, each one of these sockets, but they are all in parallel. So you wouldn't necessarily get, that much current out of all of them at once, but each of them individually, I suppose, would give you that current. But on top of that, there's no distinction between them. They're identical. They're pretty much identical. I think the only thing that's different is the way that the data pins are jumpered, but either way, it'll deliver whatever you need. The voltmeter is quite interesting. So it takes 12 volts from this plug here, and it just senses the input. So it has, like, let's say power, ground, and then another power to sense the input, and then it has another one to sense the 110 volts. It displays the 12 volts on one and 110 on the other, or whatever, the AC on the other. That's pretty interesting. These AC sockets here are absolutely inadequate. Tiny little wires, and this one is just bridged wire to wire, and they saved on connectors by just soldering directly on. And if you look here, this one here, this wire is going over that ground prong, and given enough time, that would vibrate and it would cut through the insulation. So you'd be actually, making one of your connections, one of your either the line or the neutral would be on the case ground of whatever device you put in there. Really interesting. Now, this thing does not have even near adequate input capacitance. So we have 2200 microfarads times 4, not a lot, and output, same thing, 68 microfarads, 400 volts. Pretty sad. It's got a little beeper over here. It's got a little bit of, track reinforcement. So it's got solder on top of the tracks to try to increase the current handling capabilities, but this thing is pretty sad. I would say no more than, like 400 or 500 amps, and I think that's peak 550 amps. This thing probably is more comfortable around the 300 amp or 300 watt range, I should say, not amps, watts. So yeah, 500 watts peak. I think I would run this thing over about 300 for normal use. And so here it is back together. Would I recommend this? No, not at all. First of all, like we said, 500 watts peak as a maximum, I would say. The fuse is internal. I mean, it would have been great to have it somewhere out here. External. 3 outlets, but really, maybe it acts as a power strip if you have, couple lights max. The charger, very basic. This is not your solution if you want something reliable. This is probably something you can use to have fun with. Tear down, take a look inside. Probably trying to find an aluminum case like this would probably cost you about $15 here in Canada. And hopefully it still works. It does indeed. So there we go, 116 volts out and 12 volts in. All right, well, hopefully that was a satisfying video for you guys, and it's thanks to you guys using Amazon affiliate links that I can buy these kinds of things for Teardown and to take a look at. Thanks for watching.